Welcome, guys. I am unfortunately out one last day. We are moving into our house today, so we have quite a bit on our agenda. But you guys, I can get you through at least the notes for today, and then I wanted to talk about kind of the walk up to the test for you. So today we're going to go through the linear pair angles, or I'm sorry, the vertical angles. But tomorrow is the big day that I wanted to emphasize because if I'm not here today, tomorrow's the last day we have to review prior to our assessment realistically. So just be aware that I will be going over all of these worksheets tomorrow as needed. So I'll basically start at worksheet 8, cruise through worksheet 9, 10, 11. Make sure to bring your questions to class. So if you have some, I can address them right away. Any extra time that you guys have, I will give you guys for worksheet number 12. I will probably lighten the load for you guys a little bit that day as well, just to make it a little more fair for you guys. But I'll make sure that I really hit home on a lot of the things that you guys will probably see on the assessment or something similar in that manner. But today we do have linear pair and vertical angle notes. I believe these are on page 17. So let's go ahead and cruise through these real quick. So we're going to start with some definitions of some words. Adjacent angles are just angles that have a common arm. I call them like neighbor angles. You might have heard me say that already. But you could draw two straight lines however you'd like to, and then just put one line in the middle. So these two angles that we see here, even if you want to give them names of angle 1 and angle 2, you notice that they are actually just sharing some sort of a wall. That's about it. This wall right here is the wall that they're sharing. Those would mean that they are quote unquote adjacent for you guys. And then we have these things called vertical angles. Vertical angles are created by actually creating two straight lines that intersect each other. Doesn't, again, matter how they intersect each other. They're going to intersect at one single point. But the big emphasis of this one is that vertical angles are the angles that are opposite of each other when this does indeed happen. And you can see that we actually have two sets of vertical angles, the ones on the right and the left, the ones on the top and the bottom. So every time two lines cross paths, we will see two sets of vertical angles. And the coolest thing that we know about these angles is we also know that these are congruent. So vertical angles like this are congruent. Vertical angles on the other side are congruent. Now, good reminder, we've used the single tick marks already, so we can't use those again. So another variation that you guys might notice is one that looks like this. Again, those tick marks, any angle with those tick marks are relating to them being congruent. And then lastly, we have this thing called a linear pair. These are basically two adjacent angles that are supplementary at the same time. This is actually how we ended up drawing most of our supplementary examples anyways. Something along the lines of this, where again we say that I have angle number 1, I have angle number 2. They are adjacent because they are sharing this edge wall right here. So we would consider them adjacent. They are also supplementary because they are adding up to 180 degrees as well. So those, again, things that we've kind of talked about already, but come into play a little bit with these vocabulary words. The vertical angles theorem, I briefly touched base on this already. This is just stating that when I have a set of angles that look like this, where I have one line crossing paths with another line, what we're going to end up with is two perfectly congruent set of vertical angles. Again, here are some. If you want some more different tick marks, you guys can utilize something like that. But in the situation we're really looking at, what they're saying is angle 1 is actually congruent to angle 2. And then angle 3 is congruent to angle 4, which means they are identical, measure the same, good to go. Linear pairs, something similar, kind of like I think an intuitive kind of process for this. If you have a set of linear pair angles that looks something along the lines like, I don't know, this, for example. There's some crazy car outside right now. But we got two different angles that we look at, and we could say, hey, if these things are linear pairs like this, I know angle 1 plus angle 2 must equal 180 degrees. Again, that kind of naturally makes sense since we talked about yesterday how supplementary angles must add up to 120. They're just mentioning that if we also throw in the linear pair, the adjacentness of this, pretty much the same stuff we already know. Now the fun part where we get to look at are some of these angles and how they're related together. So I'm going to kind of highlight these to differentiate which ones we're using. So if we wanted to talk about a linear pair, dang it, one last try. Couldn't do it. Okay. Linear pair, I'm going to go ahead and put these as purple. Let's do vertical angles. I'll do gray. And let's do green for adjacent angles. So basically, I'm going to highlight these, and as we go through, I'll highlight the answers over here as to what I think they're going to be. So angle 1 and angle 2, if we look at these right away, angle number 1, I've got right here. Angle number 2, I've got right here. If we actually outline these two lines right here, you'll notice that those are actually going to be those vertical angles we talked about, where again, you have to hop over the line, the same lines twice that you see there, the intersection of those two lines. So if we call those vertical angles, I believe that is the color gray that we've got going on. Boom. Next up, I have angle 2 and I have angle 3. So if I look at angle 2, we're looking right here. If I look at angle 3, right here, it does look like these things are sharing some sort of a common wall right here. So to me, again, I'm looking at that and thinking those must be adjacent angles. Number 5 and number 7. Here's number 5. They've talked about number 7 as being this angle right here. Similarly, if we look at these, angle 5, if I outline it, angle 7, if I outline it, they're once again sharing a wall right here. I would consider those to also be adjacent. We'll keep the highlighter green. Angle 3 right here. Angle 5 right next to it. I think I'm missing a color because this looks like it is a good old-fashioned none of the above for this one. Those do not share a single wall. They are not quite vertical angles. Remember, vertical angles are made from two straight lines. Angles 5 and angles 3 are really kind of offset a little bit. In a linear pair, it looks like we're missing out on angle number 2 if we really wanted to complete that extra piece of pizza there. So I will go ahead and highlight that. Oops, I think I had it as gold. No. There it is, orange. We'll highlight this as orange. Last but not least, we've got angle number 7. So I'm going to highlight that angle. Number 7 looks a lot like this right here. And the angle created by number 2 and number 3. If we look at that, that is this angle right here. And again, we're talking about this angle and this one. Those again do look like they are vertical angles in that sense. The angles made across from each other from those straight lines. We should have a gray. Sweet, we didn't have any linear pairs. Look at that. You know, it would be a linear pair. Oh, wait. Oh my gosh, guys, I missed it. I was going to say, I knew there was something wrong. Look at number 5 and number 7 again. If I did this one at number 5 and I did number 7, yes, they are adjacent, so technically you could have given them the green, but they are forming that straight line all the way across, so those are indeed going to be the linear pair there. Almost missed out on them. They're purple. Cool. Sketch an example of angles that are adjacent. So we're going to give you all these rules really quickly of how I want you to sketch things. And I'm just going to remind you of what each of these means. Adjacent means neighbors. Congruent means equal measure. And supplementary adds to 180 degrees. So we're trying to find angles that are touching each other, that are congruent, and that also add to 180 degrees. If we think about it, I kind of like to start actually over here with supplementary. That's usually pretty easy to start with just because you know that there has to be some sort of a straight line. Supplementary gives us a 180 degrees. And then next thing I'm thinking about is neighbors. So that's kind of like a similar picture where we've drawn this extra line here where I could have two angles at any point in time that are going to be quote unquote neighbors. They share this wall that I have right now. And then they have to be congruent, which actually means that this has to be perfectly straight up and down, which would split 180 into 90 and 90. So what do we know about these two angles? Well, these angles have to be right angles now at this point in time. So the idea behind this is if two angles are supplementary, meaning they're adding to 180, and they are congruent, those angles must be right angles. And again, that logic kind of makes sense as you break it down slowly. Looking at some examples, angle 1 and angle 2, looks like we have these guys as complementary right here. Oh, guys, this thing doesn't work as well as I thought it would. If they're complementary and adjacent, then that means they must add to 90 degrees for the complementary part. So I'm going to start with a 90-degree angle. Adjacent just means that they are next to each other. They're going to share some sort of a wall right here. They didn't tell me anything else, so I don't know that it bisects it. So I'm just going to kind of draw it, maybe one a little bit bigger than the other one. We've got the relationship of these two angles. I do know that they're going to add to 90 degrees. They give me a little more information. I'm going to say, hey, angle number 1, which I'm going to put right here, and angle number 2, which I'm going to put right there, have measures of 4x plus 12. Angle 2 has 3x plus 8. And as we probably know, similar to yesterday, these are going to be complementary. So if we have to solve for x and then the measure of both those angles, I know that I could take the angle number 1, I could add the angle number 2, and those should equal 90 degrees. Doing a little math, combining your x's, combining your normal numbers together, subtracting your 20, dividing by 7. I find out that the answer of x is 10, but again, they would like the measure of both of those angles. To me, I'm looking at this one as actually being the easiest one to plug something into, so I'm going to take that one and plug it in over here. I'm going to take 3 times my x value plus 8. That's going to be the angle number 2. If I have that, that should be 38 for angle number 2. And then again, if you want to plug in an x for the other one, you're more than welcome to. But really, angle 1, if they're complementary, means that it's 90 minus whatever the heck I have right now, which should end up to be 52 degrees. So again, we've done problems similar to this already, just kind of adding more verbiage and vocabulary to them. Given angle 3 and angle 4 form a linear pair, so these must add up to 180 degrees at some point in time. Again, I just know that they're a linear pair, so any of these are possibilities. Draw something that makes a little bit of sense, maybe one a little bit larger than the other. You don't want to draw them perfectly up and down just because we don't know that they're perpendicular. And then again, they're giving me some angles. They got angle number 3, angle number 4. Didn't tell me the order, but they did tell me that angle number 3 is 3x plus 95, and that angle number 4 is 12x minus 20. Once again, small plus small is going to equal large. So if we take our first angle and we add it to the second angle, this should add up to a straight line. Combine your like terms together. Subtract your 75. And your x value is 15? No. 10. What do we got here? 7? Yep. There it is. Determine the measure of the larger of these two angles. So if x is 7, again, I either have 3 of something or 12 of something. Well, this one might be actually close just because I'm subtracting 95. So I'm going to have to kind of guesstimate on one of these and just plug it in and see if it ends up being larger than 90, because that would mean the other one would ultimately have to be less than 90. So I'm gonna go with my gut instinct and do this one, but I think I might be wrong on that. Let's take that as 12 times 7 minus 20. So this would be 84 minus 20. Ooh, I was wrong indeed. This one does end up to be 64 degrees for the measure of angle 4, which again, if we wanted to do this simply, we could do angle number 3 is actually just 180 minus that value. We do end up with a slightly larger degree angle there, so it looks like angle 3 is the largest one. Last two problems. For this diagram, the first things we're going to find are x and y. If I look at these two right here, I do notice that I have a set of vertical angles. I can take those vertical angles and set them equal to each other. That would help me with some x's. So let's do 4x plus 16 should equal to 6x. We'll subtract the 4 x's. We'll divide by 2. X should be equal to 8. Now, if we wanted to take a gander at the other portion of this, I do look at this, and we can use either combination. I see these two right here should add up to a straight line. I also see that these two right here should add up to a straight line. Use whichever seems the easiest. I think these two numbers seem the smallest, so I'm going to utilize those. I know what x is now, so I can just plug that in. I have 6 x's, or 6 times 8. Add in the other number. Those should add up to 180. 6 times 8. Subtract. And I don't know. Is that, we got to bust out the calculator for this one, boys. Let's see what we got. It is 12. Oh, I knew it was a whole number. The 11s always get me once I get over 9. 11 times 9. All right. Let's look at find the measure of all 4 angles now. So again, I can just label these really quickly. Let's do angle 1, 2, 3, and 4. On a test or something, I would definitely tell you this stuff. Let's go ahead and start with some of the ones that we know. For example, angle 3 is going to be 6 times x, which I get an 8. 48 degrees. We also know that vertical angles are going to be congruent to each other. So I can say angle number 2 is actually also going to be 48 degrees. The other two are supplementary. Angle 1 is going to be supplementary to angle 3 right here. So I know that angle 1 should be 180 minus whatever I have, 132 degrees. And then again, because angle 1 and angle 4 are vertical angles, they must be congruent to each other. I end up with this also being 132 degrees. So that's a nice little puzzle. Just be careful. I think some people might look at this and they might think, okay, I can do this first, where I take 4x plus 16, add it to 11y, and get 180. The only downfall of that is that you do get x's and y's, so you have to be a little bit careful. We need an equation of some sort that only has one letter in it. Last but not least, angle 1 and angle 2 are vertical angles. I like to draw vertical angles by drawing 2 perfectly straight lines. Angle 1 and angle 2 just have to be vertical angles. They didn't tell you which ones exactly they were. From here, angle 1 is going to be x squared. Angle 2 is going to be x plus 20. Find the measure of both of those angles. Once again, ladies and gentlemen, we have ourselves some nice vertical angles. So that angle is congruent to this one, which means I can set them equal to each other. This is a fun one where we're actually going to have to take both of these values and move them over to the left side. That x squared is kind of messing things up, but x squareds work really well when we can set them equal to 0, like we see here, because this is factorable, actually. Whoa, blast from the past. X minus 5, x plus 4. We take each individual one and set them equal to 0. One of my answers is x equals 5. Take the other one, set it equal to 0. X equals negative 4. Both of these are possibilities. Ooh, this is a good one to talk about. So I would actually take either of these answers as x's. I think most people would probably look at this and say, I can't have a negative x value. But if you take negative 4 times negative 4, you do get a positive 16. And then negative 4 plus 20, you also get a positive 16. So technically, I think either of these would realistically work for us. But let's just roll with the positive one anyways. X equals 5. If that's the case, measure of angle 1 is going to be 5 squared, which is 25 degrees. Measure of angle 2 should be exactly the same, which is also going to be 25 degrees for you guys. Awesome. You guys have that one worksheet. If we look at it all the way at the top, worksheet number 10, ladies and gentlemen. I will be back tomorrow. I will be going over homework for you guys. Come in with some good questions. Take care, guys.